Hello students, in this video I want to explain a little bit about levers. So what is a lever? Lever is going to be a mechanical device, that we use to uh, lift objects, in this using this mechanical device is depending, of the relative position of the load you want to lift and the force you apply, do we have something that is called the mechanical advantage. And this mechanical advantage, when it's greater than one, means that you have to exert less force to lift a heavier object. We have three different kind of levers here that we classify. So this one is what we call a class 1 lever. This one is a classic lever, to lift objects, right? We have this other lever here that is called class 2 lever, and we have this other lever here that is called a class 3 lever. Now, why is class 1? Class 1 is because we have the fulcrum, and the fulcrum is just basically this point where we have like a pivot. And this fulcrum, you find that the load you're going to lift is to the left, for example, of the fulcrum, while the force you have to apply to balance the lever, right, is to the right of the fulcrum, or vice versa, the load to the right and the force to the left. Now, a class 2 lever is a lever where you have the fulcrum in one extreme, right, and then you have the, the load you're gonna lift between the fulcrum and the force that you're going to apply. And you have the class 3 lever, that is a lever where you have the fulcrum in one extreme, and then you have the force between the fulcrum and the load you need to lift. Usually in mechanics, right, we use levers class 1 and class 2. But when we are working, with human limbs, uh, we have levers that are mostly class 3 levers. The good thing about class 1 and class 2 levers is that this mechanical advantage that I mentioned is greater than 1 for class 2 and class 1 levers. The bad thing about the class 3 levers is that the mechanical advantage will be lower than 1. So the big deal here is that when you are holding something, for example, in your hand, as you're going to learn reading the lecture, the force that is acting on your biceps is greater than the weight of the object you are holding in your hand, right? I will show you later a video. I will be posting soon a video using some devices that I have at the physics lab, where I will show you how the force acting on the bicep is multiplied, by a factor of 6, a factor of 7, or multiplied by a factor of 6 or by a factor of 7, the weight of the object you are holding in your hand. Now, to solve problem with levers, we have to use uh, the equations of equilibrium. So we're going to use equations of equilibrium. When you use the equation of equilibrium, we have, three equations if you are working in two dimensions. So you have that the sum of the torque is equal to 0, and usually we take the torque positive when it's counterclockwise. We're going to have that the sum of the forces in x, is equal to 0, and we're going to be taking positive, the forces that are pointing to the right. And we have that the sum of the forces in y are equal to 0, and we're going to be taking positive those forces acting up. So once you know these equations that are called the equations of equilibrium, we can solve problems involving levers and some other problems. So, for example, let us try to figure out how to solve this level class 1 that we are representing there. So I will just reproduce the level again here. So I have here my bar, a read bar, and then we have a fulcrum here. 1 meter to the left of the fulcrum, we have a mass M that is equal to 2 kilograms, and of course the weight due to this mass of 2 kilograms will be pointing downwards, in this form, and that weight W will be the product of the mass times the acceleration of the gravity. We have also a force F that is over here, and the force F is acting 2 meters from the fulcrum. So of course, if we want to have this leveling balance, we need that the force F be pointing also downwards. So now, as I have just only one unknown, that is the force F, what I'm going to do is to apply the equations of the sum of torque. I want to use the sum of torque respect the fulcrum, that means respect the point A here, that is going to be here, and doing this sum of torque, I will be able to find the force F that is going to balance this lever. So the question here is this: what is torque? Torque is the product of a force times the distance, that this force is applied from the pivot point. In this case, the distance from the fulcrum. So if we know this, I'm going to say the sum of the torque, right? The sum of momentum respect point A would be 0. I will take counterclockwise, the positive. So I say, what is the torque that the weight is making here? Would be the weight times the distance from the mass to the fulcrum. So the weight in this case is mass times gravity times 1 meter. This is the torque due to the weight of the object. And this is acting counterclockwise because if you don't have the force F here balancing, your lever, this is going to move in this way. So now we're going to add here the torque due to the force F, right? So, of course, the torque due to the force F, if you don't have the mass, you only have the force F. The force F is going to make the reed bar move in this form. So it will be clockwise, right? So it's going to be negative. So that's why I say minus my force F times the distance from the force F to the fulcrum, that is 2 meters. And all this is equal to 0. Now, what is the mass? The mass is 2 kilograms times the acceleration of gravity, let me round it to 10 meters per square seconds, times 1 meter, that is the distance from the mass to the fulcrum, minus, I will be adding 2F to both sides, so we'll bring the 2F to the right, so I'm going to say equals to F times 2 meters, right? So now, what are we going to say here? I'm going to say, okay, 2 times 10 is going to be 20, times 1 is going to be 20, so I have 20, I have 20 kilograms, I have 20 kilograms, meters times meters is going to be meters square over second square equals F times 2 meters. So I will divide now by 2 meters, so I get 20 kilograms meter square over second square divided by 2 meters is equal to F. So I will simplify this meter over here with one of the meters of the meter square. So I will divide 20 by 2. So I'm going to get now that my force F is equals to 10 kilograms meters per second squared, and kilogram meters per second squared is Newton. So I have a force of 10 newtons. So what is the mechanical advantage in this case? Well, if you want to find your mechanical advantage, you say, what was the weight of the object, that I wanted to lift? It was 20 kilograms meters per second squared. That means 20 newtons. Divided by what was, in this case, the force that I really had to apply to lift or to balance those 20 newtons, those 10 newtons. So my mechanical advantage, you simplify newtons and newtons, and you say 20 divided by 10. My mechanical advantage here is 2. Mechanical advantage doesn't have any unit, right? The mechanical advantage doesn't have any unit. So mechanical advantage is 2. So that means that I apply just half of the force, that is half of the weight, right? Because I have a mechanical advantage of 2. It's like I multiply the force that I apply by 2, right? So the dimensions of this lever, the characteristic, the physical characteristics of this lever are helping me a lot, when I am lifting the weight, right? So this is a solution of a class 1 lever. I'm going to explain now. A class 2 or a class 3 is basically the same thing. I'm going to explain very quick a class 3 lever to show you, what happened with the mechanical advantage. So we have this class 3 lever here. I said that the mechanical advantage here would be lower than 1. So I have my fulcrum, I have the force F that is 1 meter from the fulcrum, I have the mass of 2 kilograms, that is 3 meters from the fulcrum. I have the same rigid bar with the same 3 meters of length, right? But now, I have changed the position of the fulcrum, and I have changed also the place where the force is acting, and the place where I have the weight, the mass, that I want to lift. So when I apply now the equations of equilibrium here, that means when I apply this, when I do a sum of torque, in this case, I'm going to say that the sum of the torque respect point A would be 0, and we take counterclockwise positive, So what is going to be, in this case, the force counterclockwise, or the torque counterclockwise? So the mass M have a weight here, W, that we know that is mass times gravity. The problem here is that if you don't have the force F that balance the lever, due to this mass and its position respect the fulcrum, this will be moving in this way. So if it's moving in this way, this will be moving then what? Clockwise. So if it's clockwise, it's going to be negative. So I have here, a negative 2 kilograms. This is the torque due to the weight, negative 2 kilograms times 10 meters per square seconds, the acceleration of gravity, so mass times gravity, times the distance of the mass from the mass to the fulcrum, so times 3 meters, then plus y plus, because now analyze what is the force doing. Now imagine we don't have the mass M, we have just the force, right? So if you have that force only, how is gonna move the bar respect the fulcrum? It's gonna move in this way. So it's gonna be moving counterclockwise. So I'm gonna say it's gonna be positive. So it's gonna be force F black, force F times the distance from the force F to the fulcrum. So the distance from the force F to the fulcrum, would be in this case 1 meter. So times 1 meter, that will be equal to 0. So if I multiply now here, I say negative 2 times 10 is negative 20, negative 20 times 3 is negative 60. So I have negative 60, kilograms meter square over second square equals negative force times 1 meter. Negative and negative will be positive, so I don't worry about the negative signs here. So I will divide by 1, so I say 60, kilograms meter square over second square divided by 1 meter. That will be my force F. So I simplify this meter with this one, so I get now basically here a force of 60 newtons. So my force here is equal to 60 newtons. So if I want to lift, right, if I want to lift this object that has basically uh, 2 kilograms, so we're talking about 20 newtons, I need a force of 60 newtons. I need a force of 60 newtons. So what we said about the mechanical advantage in the previous case, we said, okay, I will divide, the weight of the object by the force I have to apply, and then I will find like that a mechanical advantage. So if I want to find mechanical advantage here, I say what was the weight of the object that I was trying to lift? It was 20 newtons divided by what is the force that I was applying, that I have to apply to balance the lever. I have 60 newtons. Newtons and Newton cancel out. 20 over 60 the same that 2 over 6, so it's the same that 1/3. So my mechanical advantage here it's lower than 1. It's 1/3, so it's lower than 1 means, that instead of gaining force, I am losing my force. So that means I have to apply more force, than the weight of the object. So this is what levers is about, right? You must practice and you must study what is in the book about levers, right? And I hope you will be able to understand this topic. So in the next video, I will then discussing about the action of a force applied on the shoulder of a person and how the force can topple the person, so it's in some way an application of the equations of equilibrium, to a human body. So thank you for your attention.